talked about how we were going to deal with these multiple representations, and hopefully there would be a comfort level by the end. And although we're not done with chapter 8 after this lesson, we do move on to some calculator stuff. So this really is hopefully an opportunity to feel comfortable with these representations. So we learned about the multiple representations. Today your team will develop methods for writing an equation from a graph. As you find ways to write equations based on the graph, you'll build a deeper understanding of exponential functions. So I always like to start with the table first, personally. I just think it's really easy to get confused by this. So I know if I have an x-intercept at 5, and then from there it looks like I add 2 on the y. Add 1 on the x, add 2 on the y. What would my b be? Well, 5b equals 7. So b equals 7/5, which is 1.4. So I get an equation y equals 5 times 1.4 to the x. And again, I'm not sure how obvious that is to some of you guys without the table. I don't know. To me, it's not terribly obvious, so that's how I like to do this. So -1, I have 120. Here I have 0.40. My multiplier, 120b equals 40. I divide by 120, and obviously I get 1/3, right? Simplifying that. So my equation on this one is going to be y equals 40. Don't forget my zero term is 40 times 1/3 to the x. Missed. Well, there's an x there. Maybe I should redo it. I hate my sloppy handwriting, and it's worse with the stylus. Okay, here. I know I have 0.018 and I have 0.518. So my b is obviously 1. I'm just multiplying by 1. So kind of an interesting one here. That we talked about this again at the beginning of chapter 8 as well. Sort of that linear thing because we have a multiplier of 1. And then here's where I want a lot of focus on this one. So what happens when we skip? And here's what I mean by this. I know 0.7, I don't know 1, I don't know 2, but I do know that 3 is 56. Again, algebra is going to be fine here. I have 1b, which takes me here, a second b takes me here, and a third b takes me here. So what I'm really saying is 7 times b times b times b, right? 7 times 1, 2, 3 b's is going to equal 56. I can divide by 7. I'm going to get b times b times b is obviously b to the third equals 8. Now I can cube root, right, to undo this. Cube root undoes the cube, so I get b equals 2, which makes a lot of sense. 7 times 2 is 14. 14 times 2 is 28. And 28 times 2 is 56. So I'm going to get the equation y equals 7 times 2 to the x. Again, a lot going on with this one. Using that algebra there to determine how many b's there are. And then it's not a square. This one's a cube. There's 3 b's there, so I have to cube it to get back on that. And then I can check my answer once I know what the b is. So Errol and Sandy were working on writing an exponential equation in the form y equals a times b to the x using this graph. And by the way, this is kind of cut off here, but they show you it's 0.0032. So this is 0.0032. I don't know why I got cut off. So it says, while trying to write the equation, Errol stated, I think a must be 10. Well, I think that's pretty smart. That looks like the y-intercept at 0, 10. Do you agree? I absolutely agree. Nice job, Errol. So, but we still don't know what b is. And again, we can say 0, 10. I don't know what 1 is. I don't know what 2 is. I don't know what 3 is. I don't know what 4 is. But I do know that 5 is 0.0032. That's going to be 1, 2, 3, 4, 5 b's. So 10 times b to the fifth is going to equal 0.0032. Divide that by 10. I get b to the fifth equals 0.00032. The question is, well, how do I do this? Well, I need to know what the fifth root of b to the fifth is. And this is something that I don't expect you really probably know how to do. In this calculator, if you have this calculator, and if you're using like a iPhone or something like that, I don't know what to tell you. I don't have one, and I'm not good at those calculators. However, with these ones, it's kind of interesting. We're going to go to the math button here, And you can see on the math button, we have these different things. We have cube roots, but that one, the fifth one where it says x, and then it gives us the square root, that's the one that we're going to want, but we have to tell the calculator what we want for x, and we want it to be 5. So I'm going to hit 5, math, and then I'm going to hit 5 again, or I can just go down and hit enter, and you can see it turns it into the fifth root. Now I'm going to say a 0.00032, and I get a multiplier of 0.2. And let's see if this works. If I take 10 and just start multiplying it by 0.2, I get 2. I get, oh shoot, okay, so 2, I didn't multiply it, so 2 times 0.2, I get 0.4. This is going to be 0.08. This is going to be 0.0016. Actually, maybe I have one too many zeros in there. I better not get too cocky. 0.08 times 0.2, 0.016. Yeah. I'm glad I double checked it. 0.016. And then if I multiply 0.016 times 0.2, I should get 0.0032. So that worked out well. I do know that my equation is going to be y equals, here, a multiply, my starting point of 10 times 0.2 to the x. Now, I hope that makes sense of how I got that b here. They did it a slightly different way in the book. They said they don't know what the b is, but they do know that if you plug in 5 for x, right? So here's where they're at in their equation. Right now they have this as their equation. And what they said was, look, x is 5, so take the x out and substitute it with the 5, and y is 0.0032 out, so take out the y and plug in 0.0032. So this is what they did. And then they just solved this equation. And they could solve this equation algebraically the same way that we did. And a matter of fact, I'll do that real quickly just to sort of reinforce what the book is doing on this one. We have 0.0032 equals 10 times b to the fifth. We divide by 10. We get 0.00032 equals b to the fifth. We fifth root these things just like we did. And then we know that b equals 0.2. So we'd already done that math anyway. I prefer the visual of the table. You might not. You might want to go straight to the equation. You see you get the same answer either way. It's totally irrelevant. I prefer the table though. Like I said, I like to see that visual and know that how many b's I have exactly. I don't know. It's just the way. I think it's one of those things where you learn to do it one way and you just sort of stick with it. And that just feels like the right way, even if the other way might be a little bit faster sometimes. So that's what I came up with. We already wrote the equation to this. Like we said, in case we forgot, we said it was y equals 10 times 0.2 to the x. At that, let's go ahead and finish this thing up. So 868, I think it's the last problem we're probably going to do here. It says, use Errol and Sandy's method to solve 867. Again, I don't really want to use Errol and Sandy's method. I want to use mine, although I guess we could use both and just sort of see which one we feel more comfortable with. It doesn't really matter, but I have 0, 5. I don't know what 1 is. I don't know what 2 is. I don't know what 3 is. I know 4 is 1280. That gives me 1, 2, 3, 4 b's. So I have the equation 5b to the fourth equals 1280, which makes a lot of sense because what they're going to say is you're going to use the equation y equals 5 times b to the x, and then, hey, look, my x is 4, so I can change this to a 4, and my y is 1280, so I can change this to 1280, and you get the equation 1280 equals 5 times b to the fourth, which you'll notice is the exact same one we get either way. It doesn't matter. So I'll divide by 5. b to the fourth is going to equal 1280 divided by 5 equals 256. Again, I now need to, I guess I'll go sideways, I need to fourth root these things. So I'll grab my calculator, I'll go 4 math, option 5. So the fourth root of 256 equals 4. So I know that b equals 4. So my equation here is going to be y equals a is 5, b is 4 to the x. And again, we can double check that. 5 times 4 is 20. 20 times 4 is 80. 80 times 4 is 320. 320 times 4 is 1280. So we feel pretty confident with that. So hopefully you feel comfortable either way, and can skip from one number to the next without having to worry too much.